Alright everyone, today we're going to be building a Wordle game from scratch, mostly just as a way to get introduced to V and to learn their TUI package called Term. So V is a fairly new language, I'm just going to show you guys how to install it, but pretty simple. You just git clone the repo. Alright, and I just removed it from my system so I could show you guys from scratch, and then you just cd into the directory that it just made, and you just type make. So this will take just a little bit. It basically is just going to compile V with the C compiler, and then I believe it compiles V with itself, and then just does some optimizations just to make sure that it is all good. All right, and we are all good. And then the only thing we need to do is go I think it's cd. We're already in V. I think it's like /v symlink sudo that. Cool. So now if we type V, we get the V REPL. Sweet. All right. So we can go ahead and close this tab. So that's how to install V. And then I have a Wordle words list right here. So I'm just in a directory code V Wordle, and we're just going to go words.txt, right? And we're going to come over here to the raw version of this page, hit a Control A, Control C, and then paste that in. All right, so now we've got our words list, right? So this is 14,855 words. This is just all of the valid words possible in Wordle. Of course, the actual game has a much smaller subset of that they've actually used so far, but these are the valid words. We're not going to do anything too fancy about limiting the possible words for the random word. We're just going to use the entire list, right? And then we're just going to go main.v. So the way that you declare an actual main file in V or any file, start with a module definition. So module main has a special meaning. There's only allowed to be there's only allowed to be one of each module, but there's only allowed to be in main one entry point main, right? The first thing we're going to do is we're going to do our imports. So currently we're just going to need OS and rand and time. We will get the terminal part in a second, but this should get us started. So we start off, main declaration is just that. When you pass arguments to a function, they start with the name, so we can say foo, and then the data type, and then return types go over here. Main doesn't take anything. So the first thing we're going to want to do is we're actually just going to want to open this file. So we can just call this file, and we use the colon equals operator, and we say os.open, and we just pass this a string. So words.txt, and this function can return us an error. So we just need to throw an exclamation mark at the end of it just to bubble up that error just in case it does happen. And this will also exit the program because it's in main. Right, now we have our file open. Next thing we want to do is we want to start reading these words in. So we want to declare a mutable buffer, and this is going to be a buffer, an array, slice with the square brackets of the type U8, and I want to just go ahead and give this a length of 7. 7 because I believe that the word that's being read in needs 7 bytes. It might only need 6, but just to be safe, we're going to go 7. Hello is 5 bytes, the new line is 6, and the null byte is 7. So we're just going to go 7 just to be safe. Right, and then the last thing we're going to need out here is we're going to need the actual list of words. So I'm just going to make this an array, and this is going to be an array of strings. All right, then what we're going to do is we're actually going to read in one word at a time. So we're going to go for, and then file, and the way we do this is we go read bytes, and then into new line. So what this is saying is we're going to read bytes into a buffer, stopping at every new line, and we have to pass it a buffer, and we say mute buffer because we need to tell it that this buffer is allowed to be modified. And we're going to throw an exclamation mark at the end of this because this function can also return an error, but if it does return an error, if we're not able to read the file, program isn't going to work, so we want to exit. The other way you can handle this is by using an OR syntax, and this either needs to exit the program in this OR block or return something that has the same type as whatever this returns. This function over here returns an integer, so you'd have to use an integer in here, but it doesn't really make sense in this case. Right, and then the only other thing is we want to say is if it reads more than 0 bytes, which hopefully it does. If it doesn't, then we have an error. Then what we want to do, now those words have been placed into buff, so we want to add a word to words, so we use the left operator, and we say buff at position 0, and this is exclusive for array slicing, so 0 through 4 now, and then we want its byte stir. What this does is it creates the V string representation of whatever the bytes are. So this is, hello \n. What we're saying is we want position 0, 1, position 0, 1, 2, 3, 4, and we exclude the 5th byte. All right, that should give us our entire words list now. Now we just want to select a random word out of that. So the way that we can do this, we need to set up our random number generator, and this takes in 2 arguments. So we want the time.now, and then we want the second representation of that. And then it takes in a second thing, which we could just do the same thing. So the random number generator just takes in 2 numbers as its seed. It's just an implementation specific thing, but it's just 2 numbers to see the random number generator. And now we can select our actual word out of this. So we say words, and then at position, we're going to cast this to a U32 to make sure that it's a positive number. And it's not too big, so we don't need a 64-bit unsigned. And then we say rand.u32, and you say rand, whatever data type you want it to give you, right? And we're done with the cast there. And then we're just going to mod this by the size of the amount of words. Words.len, right? Now this will give us a random word. Only other thing we need to do, let's just print out the word. Okay. Open back up our terminal. Okay. And let's cd code v Wordle. And the way that you run apps in V or programs is you say vrun dot. As long as all of your code is within this directory or even in subdirectories, you just do vrun dot and it does the rest for you, right? So we get the random word rodeo, random word admin, napo, kikoi, I don't know how you say that, eater, right? So we get random words. So if we're making Wordle, we have our random word now. What's the next thing that we need to do? Well, we need to have a way to store what the user is actually inputting. So I'm going to call this mute lines, right? They get 6 guesses, so we're going to have 6 lines that they're going to input. And this is just going to be an array of strings. And the only thing we want to make sure is we give this a length of 6 so that when we go to print out our game board, we don't accidentally, index off the end of it. Now that the user has given us, or we have the space for the user to give us those 6 lines, we actually need to get the input from the user now. So this is where we go ahead and import term. So term just gives you the very basic building blocks of terminal control. So what we're going to do here is we're going to first set things up. So we need the width of the terminal and the height of the terminal. And you just do this with term, and this is get terminal size, right? And then we can call term.clear. And all this does is it just clears the entire screen, right? And just for debugging purposes, I'm actually going to print out the word. So we're going to say print ln word. And let's make this a little bit nicer. And we can say random word is, and then we can use the string interpolation syntax, which you just use a $ with the curly brackets. And you can actually leave the curly brackets off for single letter or single word variables. And it will put them in for you with V format, which is really nice. All right, so we're printing that out. So now we have our terminal cleared and we have our terminal size. So the first thing that I want to do is just welcome the user. So a common pattern that you'll see when using text user interfaces, terminal user interfaces, whatever you want to call them, is you actually declare your strings separately from the printing part of the string, because you need to know how wide that string is so that when you print it out, it's actually in the center of the screen or wherever you want it to be. So we can say, welcome to Wordle, right? Then what we want to do is we need to set our cursor to the correct spot on the screen so that we can print this out. It's a bit of a different mind frame you have to wrap your head around, because when you're printing things out normally, it just prints wherever the prompt is. But in terminal user interfaces, you have total control over where that cursor is going to end up on the screen. So what we can do is we can go term.set cursor position, right? And this just takes in an X coordinate and a Y coordinate. The X is left to right and the Y is top to bottom. So 0 is actually the top of the screen, and the height of the terminal, whatever that is, 100 lines or whatever, 50 lines, that's at the bottom of the screen. So the X position, we want to center ourselves. But the way that we have to think about this is we want the width divided by 2. That gets us in the direct center of the screen. But then we actually need to go a little bit further to the left, because welcome to Wordle, the W in welcome would actually be printed at the center of the screen. We want the very center of the word to be at the center of the screen. So we just subtract opening message.len divided by 2, right? And then our Y coordinate, we just say height divided by 2. Okay, so let's go over to here. Let's run this again. I see that clears our screen. We never actually printed out the word. That would be helpful. And we can just use normal print ln. And we just say opening message, right? And we see welcome to Wordle. And we see our random word up here at the top. Let me just run this again. Right, we see our random word up here at the top. And then we have welcome to Wordle. And this is in the center of the screen, right? All right. So we have printed out our message. The next thing we want to do is we want to ask the user to start the game. So let's go ahead and set cursor position. And I'm just going to put this at the bottom of the screen for now. And then y is height, right? And we just want to go println, press enter to start. Okay. And then what we want to do is we want to just do a little bit of a loop. And actually, we might not even need a loop here. We can probably just say os dot. Oh, I did this a little bit wrong. What you actually want to do is os dot input opt, because input opt actually allows you to enter a prompt, and we can say press enter to start. And what this will do is actually just pause the app until the user enters something. So now it says we're at the bottom of the screen. It says press enter to start. We press enter and the app exits. Cool. So that's the pattern that we wanted to go for there. Okay. So now what we need to do is we need to get the user's input. So we're going to set up this kind of big loop, and this is just going to be our general game loop. So for for loops in V, you don't actually need the parentheses. I put them there, but you don't actually need them. I probably would take them away if you did put them there. And we're going to say I is 0, I is less than 6, because the user gets 6 guesses, and we just go I++. So what we need to do is we need to clear the terminal every single time, and we want to print, or first thing we need to do is actually show the cursor, because when you're working with TUI, sometimes the cursor can get hidden or shown depending on how your printing is working. So we just want to make sure that the cursor is shown so the user knows to input something. And this is where we're actually going to print our board. This is a function we're going to define here in a second. We want to pass this the lines, the word, the width, and the height, just being the width and the height of the terminal. Okay, let's come down here and let's actually make this function now. So when we want to show the user the board, we basically just want to print out a whole bunch of empty spaces for each line, and we're going to do some syntax highlighting or color highlighting depending on what the condition of that letter is in the word. So the way that we define a function, as we saw above with main, you do fn, name of the function, and then you do the name of the parameter, and then the actual data type. So lines is going to be an array of string, word is just going to be a string, and then width is an int, height is an int, right? And this method does not, or function does not return anything, so we don't have to worry about that. So we're printing out the board. First thing we're going to want to do is actually declare ourselves a blank line. And this is just going to be equal to, and this is how we're going to represent our blank line or even the full line in Wordle. All right, there'd just be letters in it if it was a full line. Next thing we want to do is an offset. So the way that I'm going to be using this is that if we want to print our board centered on the screen, we don't just want to directly start at the center of the screen. We just want to offset. If the board is 6 tall, we just want to offset half of that, so just 3 tall. So the way we'll do this, it's going to start at -3, not -4, but we'll see how we increment that in just 1 second. And then we're just going to loop through the lines that the user's inputted. So for line, in lines, and this is just a basic loop syntax in V. Right, we see we have 2 different kinds of loops. We have many different kinds of loops, but these are the 2 ones you'll probably see, a C-style loop and then a smart loop. So for every line, we want to increment the offset, and then we want to set our cursor position to where this line should start. So term.set cursor _ position, right? X coordinate, same thing, width divided by 2 minus blank line dot len divided by 2. And y, sorry, this is going to go off the screen, but I have my font size big for recording. And then y is going to be height divided by 2 plus offset. So this is going to cause us to go back up because it's negative numbers at first, right? And then we want to just check if line dot len is equal to 0. So basically, if the line is blank, we don't want to try to index into that line because obviously we're going to go out of range. And in this case, we just print the blank line. And then we just say continue. If I can spell. All right. Otherwise, what we want to do is we want to say for letter in line. And we want to come down here and we want to say if letter equals line. Oh, sorry, this actually needs to be a different kind of loop. We want to have the index and the letter. So we want to say if the letter is at the line at the specific position, well, then they got it correct, right? Correct place. Else, if letter in line, this should be letter in word, sorry. This is correct wrong place. And lastly, this just means that the character is not in the word. And this is just going to be wrong, right? So the way that we'll actually handle this is by using a little bit of coloring. This is what I was talking about. So what we're going to do here is we want to go print and term. And if it's correct, we want to use green. So term.green. We're going to use a format string here. And we want square brackets. And then inside those square brackets, we're just going to print out the letter. So we do $, curly brackets. And this is going to be letter dot ASCII str. And this is just what we have to use so that it actually prints out. Because when you loop through a line, which line in this case is a string, what you're actually being yielded every single time is a byte. And when you print out a byte, it prints it out as a U8. We want to print out the char representation of it, so we have to do .ASCII string. It's a little bit weird, but it's just what you have to do to handle that. Right. The rest of these are going to be pretty much the same. We're just going to change what color it is. Right. If the letter's in the word, I was speaking and trying to type at the same time. It's yellow, and then this is gray. So what this is going to do now is going to print out our whole game board. If they only have one guess, it's going to print out one line, and the rest of the lines are just going to be printed out and covered by this blank line. All right. So that should be it for printing out the board. So we should be able to see this now. This should just give us a full blank board, and then the game should exit. So we say vrun, and letter in word. Oh, and the only thing here, like I said, letter is actually a byte. So the way that we do this is we have to do bytes to get the slice of bytes. V has wonderful error messages. All right, welcome to Wordle. That message looks a little offset in the screen. Main, welcome to Wordle. Opening message.len divided by 2. I mean, I guess it's fine. I don't know. It just looks a little off center. It's probably fine. Press enter to start, right? We get ourselves our game board and we're all good. So now we need to handle the input loop. So we print the board and our cursor is right here. As you can see, that's where my prompt started printing out again. So what we need to handle is actually getting the user's input. So what we can do after we print the board, what we want to do is set ourselves up a prompt. And this is going to be equal to a 5-letter guess. I mean, you can obviously say whatever you want, but this is just a helpful thing to show the user what to input. And then we want to set our cursor based on the width of that prompt. So we go term.set cursor position. X is going to be equal to width divided by 2 minus prompt divided by 2. Prompt.len. Is that what I missed down up here? Nope, I did len. I don't know why that was all weird. Y, maybe it's just the Emacs terminal. Height divided by 2, and then this is just +4. And the reason why we're using +4 here, right, our position that we're actually getting set to is right here, I believe. This is the center of the screen. So when we do the -3 that we saw down here, right, because this is -4, but we increment it right away. If this is our normal position, -3, we go up 1, 2, 3. That's the top of our board, and we increment this, right? And if the center of our screen is right here, if we go +4, so the center must be here then. 1, 2, 3, 4. This is going to put our prompt down here on this next line, right? When you're playing with TUI, it's kind of something you have to mess with. Sometimes you have a little bit of magic values in here. You could probably find out a way to use a variable to cover that, but you just have to adjust it to be as the positioning that you actually want. Now what we want to do is we want to go if input, and this is just a little bit of error checking. os.input opt, and we're going to use this thing again, and this is just going to be prompt, right? So this is saying if they actually input something, do this. Otherwise, the app will exit, right? So if they input something, the first thing we want to check is just a little bit of error checking. So if their length of their input, does not equal 5, or input, and V has this wonderful syntax for saying if something is not in an array, you just use !in, input not in words. So if the word that they guess is not a valid word, then what we want to do is just a little bit of an error message and then restart them. We don't want to waste one of their guesses, right? So we say prompt, we can go error message, and this is going to be equal to term.read invalid input. Okay. And then we say term.set cursor position. X is going to be width divided by 2. And we can't just use the length of this string anymore, which is kind of a downside. But when you call term.red, what it's actually doing is it's putting the ASCII escape sequence on top of, surrounding this string. So it sets the color to red, which is this like kind of weird syntax that's like, I don't remember exactly what it looks like, but it looks something like that, right? Which is like a escape sequence, and then it has to do like the reset at the end of it. So it's adding a whole bunch of bytes to your string. So what you can do, what we can't do is just use the length of this string. We just kind of have to manually do this. So it's like 7 characters, right? It's a little bit hacky. We can use 6. And then y, we just want to set this to the same thing. And we just say height divided by 2 plus 4. And I think I had this wrong up here. This one should be plus 3, sorry. I was counting it correctly. We want it to be, the center is here. It's 1, 2, 3. This error message needs to go one line below that. So sorry about that. And then we just go println error message. And let's go ahead and sleep for just 1 second, just so that the user, has a second to acknowledge they entered the wrong thing. Clear the terminal and continue. I know we clear the terminal up here, but just to be safe, we're going to clear it down here because the first time we entered this, we also need it cleared. Right. So now we're in this else branch. I'm not going to do an else branch because I don't want the indentation, but if their input is valid, then we want to set the line at position I equal to their input. And then what we say is if input equals the word, then they win the game. So we come over here and we go, you win. So this is just a little ASCII art thing that I generated using some sort of website that I found, but I'm not going to rewrite it. So it's just that. It just says you win. We'll see it when we write this in a second, or when we win the game. You'll see it, right? So you win. Then what we want to do is we actually just want to tell the user like kind of their stats. So we say print board, and this is lines word with height, right? And then we have to do a little bit of coloring here. So the word colored is going to be equal to term dot, and we're just going to make this yellow in this case. And let's go ahead and do the string, and just like that. And then guesses, and this is going to be equal to term dot, let's call this cyan, and this is going to be, need this in strings, I plus 1, because if I is on position 0, that means they got it in one guess. So we just need to add 1 to it. And then the message is going to be equal to you guessed the word, and this is going to be word colored in guesses. Right, and the same thing again, we can't actually just use the length of this string because it has all those ASCII escape sequences to set our cursor. So working this out before, it came out to just a third of the string. Looked mostly centered to me. Of course, you can always mess with this or find a different way to calculate this if you really want to. And plus 4 is going to get us right below our board like we figured out before. And we go println message term dot set cursor position. Oh gosh. Position. And this is just going to set their cursor to the bottom of their screen so that when the app exits, it doesn't get all wonky. Okay. And, oh, I actually forgot one thing. You guys are probably wondering why I had this continue here. This actually needs to be inside of another for loop. I messed that up. We can just put this anywhere. The formatter will fix it. Right. And then the only other thing we need here is just a break. So what this is saying is if their input, right, we're inside of these brackets here. If their input is valid, but it's not a correct answer, like we need to give them another guess, we just need to call this break down here because we're inside of an infinite loop right here. And the reason why we have this infinite loop is just for this error checking right here so we can continue, right? And that should actually be it. So we come over to here, we run the game again, and we just need to set some things up. So it looks like I just missed the walrus operator on some of these. If I missed it there, that means I probably missed it somewhere else. Let's scroll up to the top. Unidentified ident prompt. Prompt. I can't spell. Let's see. Prompt no value. Unidentified ident second. Oh, and that would be time.second. That should fix it. Okay. Oh, did I save the file? I did. Okay. Unidentified ident prompt online 36. Oh, I just really can't spell. I did it twice. Prompt does not return a value. Mismatch. Okay. Cool. All right, so we see up here at the top of the screen, our word is duress, and it says welcome to Wordle. Press enter to start. And I thought we colored that welcome to Wordle. Did we not? We did not. Let's not mess with it because it would mess up our spacing. Press enter to start. All right, and we have our game board. Our word was duress, I think, but let's say we enter in hello. Okay, so the only thing is, looks like we messed up the, right, it looks like, oh, so we see our U in. It's a little bit big for this terminal size, but it looks like we messed up our printing because the word is always in it. Okay, if letter is equal to line at position I, oh, of course, I'm trying to iterate through the same thing. This should be word at position I. Blat. Hello? Right, so that gives us now our gray highlighting if something's not in the word and yellow highlighting if it is in the word. And the word was, blat, I think that was the word. Yeah, there we go. And now we can see that we have our full prompt here. I mean, if this was a smaller terminal, let me just do this real quick. We can see the whole U win. So let's try this one more time with a normal size terminal. The word is puros. And we can say, just do a few guesses here. I don't actually remember what the word was. Let's say we use all of our guesses, though. Check that case. And the only thing is we didn't enter in our last case. So we must have missed something here. We just see, oh, we never added in that case. That would be helpful. The last thing we need to take care of is if they get to the end and they don't actually guess all the things. So we'll come back in here and we'll make this big again. All right. So if we're down here, I know it's hard to see with a big font, but I'll highlight that. Can we see? Yep. Highlighting that bracket there. So this means we're on the outside now. And we want to do term.clear previous line. And what this does is it will just clear this line over here, right? This line will just be cleared. That's the last line that was outputted. And we can call print board. I don't want to retype this, so we will just go and do that. All right, so we print the board out. And then let's go ahead and set our cursor to be, X is going to be the width divided by 2 minus, and we actually need to define something beforehand, and this is the same stuff that we're going to need up here. We can copy this. All right, and we can say message, final message. I think message was already taken. The correct word was word colored. And then we just say better luck next time. Right. Oh, the formatter's just yelling at us. This should be final message.len. And let's put it back, I don't know, 4 bytes. That's just a guess. Like I said, when you're making TUI, sometimes you just kind of have to fudge it around a little bit until it looks right. And we're just going to put this at the bottom of the screen. And get rid of that. I don't know why it doesn't clear back for me. And then let's just go ahead and reset their terminal to the correct spot. And there we go. That should fix all of our cases now. So let's come down here, run the thing again, lyase. I guess we don't actually care about the word because we wanted to see what happens when we get to the end. And I don't think I ever printed out the message. That'd be helpful. Println, final message. Press enter to start. Okay, Apple, hello, Apple, hello. All right, and we do need a print line somewhere. Sorry, I'm just trying to figure out where we need this to be. Oh, did I just think I missed the last part of that to put it below the board. Try this again. It still is not setting our cursor position correctly. What if we do? It's also printing out 3H. What is 3H? Do I have that somewhere in the file? Let me just debug this. What if I change this to 5? That's really weird. It's like not updating my cursor position before it's printing. Setting the cursor position right beforehand. No, I can't do that. I honestly do not know what's happening. \n. Oh, I missed the letter. Huh. Something weird is happening. We're getting an extra letter in here for some reason. 4H. I don't know what that's the or the hex representation of. Huh. Well, we're getting something weird in there when we don't get the correct answer. It's printing out before this. Last thing we called was print board. Huh. I'm wondering if we're entering this in wrong. Either way, we can just solve this by going println and doing that. Oh, this doesn't need an argument. My bad. Just pass it an empty string. I did it again. Okay, it still messes it up. Huh. So it is something to do with final message somehow. It's really interesting. It's like not setting the cursor position to the right thing. With final message .len -4. Huh. This 3H is not the same every time, or is it? What if I always guess Apple? What? Oh. Did I have a space? It's always 3H. Well, whatever. Something is messing up with the control sequences, but I can't figure out what it is. Oops, I did not mean to do that. Let's just do that, maybe. Keep doing that. Okay, I don't know what I did differently, but it worked. Something is messing up with the control sequences. But here we go. So we have the full finished game of Wordle now, and we'll just do one more run just to get the word correct. And there we go. Guessed everything right. Cool. So that's the full game, not full game, but you know, the fullest implementation we're going to do here. Let's see. In V in 115 lines, and of course, you know, 21 lines of that is just for ASCII art. So, yeah. Hope that was a good introduction to V. If you'd like to see anything else, just let me know.